All right, team, let's talk. If you're building with AI, you're constantly up against this one critical decision. Which model should we actually use in production? This choice is about more than just a list of features. It's about being smarter, faster, and way more efficient. So let's break down how we're going to make the right call every single time.
So here's the deal. We're all facing this. The language model landscape has just shattered into a million pieces. In 2025, picking the wrong model isn't just a small oops, it's a critical error that can totally sink a project with runaway API bills or, just as bad, lackluster performance that kills a feature right out of the gate.
Okay, so let's simplify this whole messy landscape into two main buckets. On one side, we've got the reliable workhorse model that, we've all come to depend on. But on the other side, there's this new kind of heavyweight, the thinker. And understanding the difference between them is absolutely key to our success.
First up, the instruction-tuned model. This is our workhorse, right? It's our default powerhouse for probably 90% of the common tasks. Writing, summarizing, general Q&A. Think models like GPT-4o or Claude Sonnet. They take a raw, super knowledgeable base model and then fine-tune it to be helpful and follow directions to the letter. They're reliable, they're fast, and they're built to just get the job done. But now we have the thinker, the reasoning model. Models like OpenAI's O1 and DeepSeek's R1, they don't just spit out a response. They deliberate. Before they give you that final answer, they generate this hidden internal monologue, a chain of thought that could be thousands of tokens long. And when I say tokens, just think of them as the AI's building blocks for language. Words, parts of words. These models literally think before they speak.
And this slide right here shows you the fundamental architectural difference. An instruction-tuned model gets a prompt and it just immediately starts generating an answer. But a reasoning model has this totally separate, hidden thinking step. That one little extra box in the process flow, well, it changes absolutely everything.
So, how does this thinking actually happen? Good question. To really get it, we need to clarify two terms that people confuse all the time. One is just a simple prompting trick, while the other is a core part of the model's actual design. Let's talk about chain of thought versus thinking tokens. This is so important. Chain of thought, or COT, that's basically a prompting hack. We can tell any model, even GPT-4o, to think step by step, and it'll show its work right there in the output. But thinking tokens are completely different. They're an innate architectural feature of these new reasoning models. The thinking is internal, it's hidden, and it uses special, costly tokens. You can't just ask a regular model to do this. It's not built that way. And the sheer depth of this internal deliberation is just staggering. For a really complex problem, a reasoning model might use 5 to 20 times more internal thinking tokens than the number of tokens in its final clean answer. That gives you a sense of the scale of the real cognitive work that's happening under the hood. Okay, all this thinking sounds incredibly expensive, right? And yeah, it is. But there's a key innovation in how these models are built that makes them commercially viable for us to even consider, and it's called mixture of experts. Which leads us to the central puzzle here. How on earth can a model with a staggering 671 billion parameters like DeepSeek R1 possibly compete on price? Well, the answer is this really clever architecture called mixture of experts, or MOE for short. See, instead of firing up the entire massive model for every single token of a request, Mo is way smarter. It uses a router that looks at each token and sends it to only a small handful of specialized expert networks. So instead of, say, 64 experts all working at once, maybe only 2 of them are actually needed for that specific piece of the puzzle. And here's the payoff. Check this out. A model like DeepSeek R1 has the encyclopedic knowledge of a 671 billion parameter model, but its actual running cost is based on only 37 billion active parameters. We get big model intelligence at a small model price. That performance to cost ratio, that's what makes this so incredibly disruptive. It's a game changer. All right, let's pull all this theory together and make it real. This is our production playbook for making the right call on any AI project, starting right now.
So first, let's talk performance. Is it actually there? On really tough reasoning benchmarks like Amy, DeepSeek R1 is absolutely playing in the same league as the top-tier OpenAI models. So yeah, the performance is definitely there.
Now for the number that changes the entire game, cost. Look at that reasoning tier. DeepSeek R1 starts at just 55 cents per million tokens. That makes it 20 to 50 times cheaper than its direct competitor, O1. This completely upends the economic calculation for using these super powerful models. So the crucial takeaway is this: we deploy these powerful but still more expensive reasoning models surgically. You save them for the tasks that truly require multi-step logic and deep deliberation. We're talking hard math, complex scientific analysis, or generating code with really intricate dependencies.
And for the vast majority of our standard tasks, they are complete overkill. For general chat, simple summaries, or basic classification, a cheaper and faster instruction-tuned model like Gemini Flash or Claude Sonnet is absolutely 100% still the right tool for the job.
So here it is, our team's cheat sheet. Before you start any new project, look at this. Think about the core task. Is it a hard logic problem? Then a reasoning model's your best bet. Is it high-volume chat? A cheap MOE model is the way to go. This matrix is our key to making smart, consistent decisions.
So the big takeaway here is simple. The era of just picking the single best model for everything, it's over. A hybrid approach, where we use a cheap model for 90% of the work and reserve the powerful reasoning model for that 10% that truly needs it, is both way more effective and far, far more economical.
So as you head back to your desks and start scoping your next feature, ask yourself this question: are you just hammering in another nail? Or is this the moment you finally need a new kind of hammer? Because choosing the right tool is now the most important part of our job.
If you found this helpful, hit subscribe and the bell so you never miss a video.